Hey guys, last time we saw the importance of a MOSFET gate driver. When we use a MOSFET in a fast switching application, we hook up a resistor between the driver and MOSFET which acts as a bridge in between. We call it an external gate resistor for the gate driver. This time, we'll get to know why we need an external gate resistor and what factors do we consider while choosing it. External gate resistors play a crucial part in many aspects. Gate drivers can cause unwanted behavior in a MOSFET switching without an appropriately sized gate resistor. The gate resistor controls the charging and discharging of the gate capacitance. This, in turn, affects the number of critical parameters such as switching time of the MOSFET, power dissipation and power losses, voltage overshoot, gate ringing, and electromagnetic interference. Let's see how. If the resistor value is small, then it charges the input capacitance faster, so turn on speed will be faster. Which is a good thing. If we increase this resistor value, then it will extend the switching time and switching speed of the device will decrease. Gate resistor affects the voltage overshoot during turn-off event of the MOSFET. A small resistor value will result in higher voltage overshoot across the MOSFET due to high di/dt. We have seen about the di/dt and drain to source voltage overshoot in one of our previous videos. A sufficiently higher resistor will limit this voltage overshoot. A higher gate resistance will slow down the switching speed and increase switching losses. Well, we can use two gate resistors for turn on and turn off of the MOSFET. We'll see about that in the next video. Gate resistance affects the rate of change of drain to source voltage, rate of change of drain current, and reverse recovery of a freewheeling diode. This behavior limits the minimum value of the gate resistance. This means that the turn-on switching speed of the MOSFET can be only increased up to a level compatible with the reverse recovery behavior of freewheeling diode. The reverse recovery current increases with the change in current with respect to time. So higher the di/dt is, the higher will be the reverse recovery current of the MOSFET. An increase in this will cause higher turn-off power dissipation in the freewheeling diode. So if you use a low gate resistance value, then also the power dissipation across the MOSFET will increase. When a low gate resistance is applied, the switching will become faster, which can reduce the switching loss. But the noise induced by di/dt and dV/dt will increase with switching speed. So the EMI of the switching device will increase with decrease in gate resistor value. Gate resistor dissipates power in the gate loop and prevents gate ringing. In my last video, I mentioned the gate driver circuit prevents the gate voltage ringing, but there is a dependency on the gate resistor. The voltage driver doesn't prevent the voltage ringing on itself. On the contrary side, due to its low resistance output, it may cause it even more. In fast switching applications, as we saw last time, gate ringing occurs due to parasitic inductance and intrinsic capacitance of the gate loop. Because of that, oscillations appear in the gate signal. For power MOSFETs, this gate ringing effect becomes more severe. To avoid the gate ringing effect, we use a large gate resistance, which will increase the damping effect and finally suppress the ringing. But again, increasing the gate resistance will decrease the efficiency. Also, too high gate resistance will decouple the gate signal which comes from the output stage of the driver. This will lead to longer delay times or even operation failure. Therefore, the value of the gate resistor should be chosen very carefully. If we summarize all of these points, When we use too small resistor value of a gate resistance, then there will be effects on the MOSFET like higher di by dt, gate ringing, voltage overshoot, and EMI. And when we use higher gate resistance value, then the switching speed of the MOSFET will decrease and its power dissipation will increase. So, selecting the gate resistance is a trade-off between efficiency and noise. We can't use a very small resistance value. Besides the value choosing, the layout of the gate resistor is also important. The gate resistor should be put as close as possible to the gate of the power device. Well, that's all about the gate resistance. Next time, we'll see different gate driving techniques. Till then, stay tuned. I've added all the reference on this topic in the description. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you liked this video, subscribe to my channel, and finally, thanks for watching.